Thank you. We are going to look at 3 of your homework problems together, and then we'll go back to the notes to finish talking about the intermediate value theorem. But I want to make sure we have time to talk about this, which is why I'm taking a break from the notes for a minute and coming over here. So we're going to explain it. I'm going to show you exactly how I want you guys to write it, etc., etc. So I kind of zoomed in. The directions got a little cut off, but it says, for problems 1 through 4, use the intermediate value theorem, IVT, definition to explain why the function has a 0 in this interval. So here are the steps that you need to take in order to show, using the intermediate value theorem, that it works. So, number 1. The first thing we have to do in order for the intermediate value theorem to work is that it has to be a continuous function. So, that's my first question for you. Is this a continuous function?
Yes.
Yes. Why? How do we know it's continuous? It's a polynomial. Polynomial functions are all continuous functions. So, the very first thing you have to state, and yes, you have to state it, you have to write f of x is a continuous function. It's not enough for you to say it to yourself in your head. You have to write it as well. F of x is a continuous function. The reason I'm stressing, by the way, the steps that I want you guys to take is because, remember, the AP tests this year, they're stressing that your justification is enough means to conclude what we're going to conclude. So our first thing we have to stress is that f of x is a continuous function. You have to write that for every single one that it asks you to use the intermediate value theorem for. So when you go home and do your homework, number 2, you're going to write that. Number 3, you're going to write that. Number 4, you're going to write that, as long as they are continuous functions. They have to be continuous in that interval, by the way. So if I gave you a different function, like for example, 1 over x minus 1, can you tell me where that function is not continuous? It's not continuous at 1, right? But what if I was talking about the interval from 3 to 4? Would it be okay to use it then? Yes. So it's okay if the function itself is not continuous, as long as it is continuous on the interval we are looking at. So for ours, it's a polynomial. It's continuous everywhere. But if we had a different function that was not continuous everywhere, just check the interval to see if the interval itself is continuous. Okay, that's the first thing. The next thing that's important to do, remember that it's asking for a 0. What is a 0, by the way?
Intercept.
It's an intercept. It's an x-intercept. In order for a function to have a 0, it means that y has to be equal to 0, that it crosses through the x-axis. So we're going to plug in the 2 points that bound this interval. So it's bound by 1 and 2. We're going to plug in 1 to the function, and we're going to plug in 2 to the function and evaluate. So do that with me. Let's find out what f of 1 is. F of 1 equals 1 over 16 times 1 to the 4th minus 1 cubed plus 3. If I add all that together, I get 16 minus 1, which is 15. 15 plus 3, which is 18. And the second bound, that's the bound on the left. Let's look at the bound from the right, which is 2. Oh, goodness gracious. Miss Martinez. What is Miss Martinez doing? Sorry. It is Friday. I got all excited about 16. My bad. Okay, let's try that again. Thank you. We have 1/16 minus 1 plus 3, which is 2 and 1/16. We better with that? Perfect. 2 and 1/16. Or if we want to write that as a improper fraction, that'd be 33/16. Whew, lo siento. I apologize.
What does that mean?
It means I'm sorry. All right.
3 years of Spanish didn't teach me.
Let's try f of 2. Let's plug in 2 to the function. That's 1/16 times 2 to the 4th power minus 2 cubed plus 3. What's 2 to the 4th power? 16. 2 times 2 times 2 times 2 is 16. So this is 1/16 of 16. Minus 2 to the 3rd power, which is 8, plus 3. What's 1/16 of 16? 1. So this is 1 minus 8 plus 3. -4. Good. Now, here's the purpose of doing this. The left bound and the right bound. Look at the answers we got for both the left bound and the right bound. Is it true that one of them is a positive number, meaning that it's above the x-axis? Yes, this one is a positive number. It's above the x-axis. Is it true that the other bound is a negative number, that it's below the x-axis? Yes, this is a negative number. It's below the x-axis. Therefore, if this is a continuous function, isn't it true that to go from 2 and 1/16 down to -4, you have to cross through the x-axis?
Yes.
Therefore, there has to be a 0 in this interval. Yes. All right, that's the intermediate value theorem. So you would say, this is our conclusion. We're going to write our little therefore. These little 3 dots, remember, mean therefore. Therefore, we have to conclude, we literally have to write everything we just wrote. Because f of x is continuous, over those prepositions are tricky. You can pretty much put whatever preposition you want. Over, on, through, whatever interval. I just like to say over the interval. You could say on the interval. Because f of x is continuous over the interval from 1 to 2, the closed interval from 1 to 2, and f of 1 is greater than 0, and f of 2 is less than 0. I'll pause there. I see some of you guys furiously writing. Because the function is continuous, because the left bound is greater than 0 and the right bound is less than 0, then by the intermediate value theorem, you can abbreviate that IVT. Then by IVT, remember that IVT stands for intermediate value theorem. Then by the IVT, the intermediate value theorem, there must be a 0. There must be a 0 in the interval from 1 to 2. Notice that this is a closed interval. It has to be continuous on the closed interval, and the 0 can be in the open interval. That is your answer, but the stuff before it is the work. Whew, it's a lot, huh? Yeah. The next part it says to use your graphing calculator to zoom in. However, that's going to take us a while, and I really don't want to do that. So, I will teach you how to use your graphing calculator to calculate the exact 0. But for right now, we're going to use Desmos to zoom in because I think Desmos is an easier tool to use to zoom. So, looking at this first function, write this down for number 5 on your homework. X cubed plus x minus 1. X cubed plus x minus 1. X cubed plus x minus 1. Now, do you guys see the 0 on the graph on mine? Yeah. All right, obviously my calculator tells me exactly what it is, but let's just pretend we didn't see that. So essentially, on your graphing calculator, you would just want to zoom until you found up to 2 decimal place accuracy what that 0 was. So notice that you can zoom in pretty far and get a pretty good idea of what it is. So 0.6823, etc. It's more than that, but less than the next one. So Desmos is kind enough to calculate it for us, 0.6823. But I'm going to show you guys how to calculate that on your graphing calculators. So do me a favor, get out your graphing calculator. Now, I'm going to teach you guys 2 ways to do this. I hate the first way. I just do. I really hate the first way. So I prefer the second way. When I do it in this class from now on, I will do it the second way. But if you want to do it the first way, be my guest. So there are 2 ways to calculate a 0 using your graphing calculator. Your calculator can do it for you. It can actually physically calculate the 0 for you. I personally don't like doing it that way because students a lot of times have difficulty visualizing the zeros, and so they have difficulty. It asks you questions, and you have to answer its questions. So, for example, it'll ask you for a left bound, it'll ask you for a right bound, and then it'll ask you to guess where the 0 is. And some students have difficulty visualizing that. So that's where I like the second place, and I'll teach you how to do that. So do me a favor, type that in, and then put your calculators down. I'm going to show you how to do it on my screen first, and then I'll have you guys try it. So here's how you calculate a 0. You push this button that says graph. Look up here at my screen for me. Perfect. You push this button that says graph, and then it's going to graph it for us. Then we're going to go to second, and you're not doing this yet on yours, so you can just put yours down. Put second, and then you guys see this button right here that says calc? Yeah. We push second, calc. Which one do you think we're going to use to find a 0? The second one, the 0. So we push 2. Now, it is going to ask you for a left bound. Here's what that means. If you had to estimate the value here, we already know it's like 0.68 something because we found it on Desmos. But you would look at your graphing calculator and you'd think to yourself, all right, that's about what? And you might say 0.6 or 0.8 or point whatever. A left bound is a number that is to the left of 0.6. What's the number to the left of 0.6? And you don't have to be close. You can be far away. 0.5, sure. How about 0? 0 is best. How about 0? 0 is great because that's definitely to the left. So, you type in 0 and you push enter. Next question is to the right. So if we're thinking in our heads that we think the 0 is at about 0.6, what's the number that's definitely to the right of that? 1 or 5 or 2 or whatever you want. I'm just going to put 1. Enter. And then it asks you to guess. So again, if we guessed that we thought it was at about 0.6, we would put 0.6. Enter. And it tells you, okay, great, it's at 0.6823, da-da-da-da-da-da.
Why does it ask you to guess?
Because it makes it easier for the calculator to calculate it if it knows where it's looking. So if you tell it it's around 0.6, it'll look close there first before it goes to other values. It makes it easier for the calculator to find it. All right. Eyes back up here. Now I'm going to show you my favorite way of doing it because like I said, a lot of students that I have, not everybody, so maybe you like that way works for you, that's awesome. But I have a lot of students that have trouble using that feature of the calculator. So I personally like a different feature that's called intersect. And here's why I like intersect. I want to know where this graph crosses the x-axis. I want to know the 0. What is y equal to at that point? What is y equal to on this line? 0. So what I personally like to do, and some people don't like this because they think it's like thinking outside the box, it freaks them out. But what I personally like to do is I like to go back to my equation and I enter in another equation at 0. So there's my first one and there's my second one. I go back to the graph and there's another feature that your graphing calculator can do called the intersect feature. So I go to second, calc, and I push 5 for intersect. Here's why I like this. It asks a couple questions as well, but it does all the work for you. It says, what's the first curve? Do you guys see up here in the corner how it says the first curve? All right, so all you have to do is push enter. It jumps to the second one for you. There's my second curve, 0, enter. Yes, that's my second curve. And then it says guess. All right, great, 0.6. And then it calculates the intersection of those two lines. So the line y equals 0 with my function, that's where they intersect. Now again, I personally like that one because a lot of times you guys try to find left bounds and right bounds and it's hard for you to visualize what it is and sometimes it just gets tripped up. So I personally like this one because it's really easy to just have the calculator calculate the intersection point for you. You can use either way though, and both of them will work. All right? So anyway, our 0 is at 0.682. We know, let me come back over here really quick. We know that the directions, by the way, say to use the intermediate value theorem and a graphing calculator to approximate the 0 of the function in the interval, and then repeatedly zoom in to find it, and then we go to the graphing calculator and use the 0 or the root feature in order to find it. So we use the 0 or the root feature. I'm going to be honest with you, there's not a ton of work to show for these, so next to number 5 on yours, let's just write that value. So we're just going to write x equals, and then it was 0.682. 0.682. You only need 3 decimal places. You don't need more. If you put more, that's fine. It won't be wrong, but you only need 3. All right. The last question we're going to look at is number 9. Write that in your homework. Number 9. Number 9 says, verify that the intermediate value theorem applies to the indicated interval. So they're not telling us it's guaranteed this time. We have to verify that it does apply. It says, then find the value of C that's guaranteed by the theorem. Use a graphing calculator for problems 11 only. And then verify numbers 9 through 12 with a graphing calculator by fixing f of x and f of c and using the intersect feature of the graphing calculator. Okay, we'll talk about that. So let's look at number 9. Perfect. Okay, so number 9. We're going to do the same thing we did for number 1, which I know you guys love writing out that big long explanation. The first thing we have to state is whether or not f of x is continuous. What do you guys think? F of x continuous, yay or nay?
Yay.
How do I know? It's a quadratic. It's a polynomial function. Polynomial functions are always continuous. So you have to state f of x is continuous. Great. The next thing is that we need to guarantee that the function is going to equal 11 on the interval from 0 to 5. So here's how we do that. We need to calculate f of 0, and we need to calculate f of 5. So for f of 0, if I plug 0 into that function, I get 0 squared plus 0 minus 1, which, if I can do my math correctly, that's negative 1. If I plug in 5, I get 5 squared plus 5 minus 1. Good. 25 plus 5 is 30. 30 minus 1 is 29. Bless you. So, we can make our conclusion now. Therefore, because f of x is continuous, please write this down. Because f of x is continuous, because the function is continuous, and, on the closed interval from 0 to 5, and f of 0 is what? In the last example we did this for, we said that f of 0 was greater than 0 because we were looking for a 0. We're not looking for a 0 this time anymore. Yeah, we're looking at 11. So we got that f of 0 is equal to negative 1. Is negative 1 greater than 11 or less than 11? Less than 11. Okay, so this is our bound that's less than 11. So we're going to say f of 0 is less than 11. And f of 5 is greater than 11. Then, by the intermediate value theorem, by IVT, there must be a C value in the interval. So on the interval from 0 to 5, remember this one can be an open interval. On the interval from 0 to 5, where f of c equals 11. Aren't you glad this isn't a heavy topic on the AP test? All right, now you may be like, yay, we're done. We're not done. Pick your pencil back up. I apologize. We're not even done with this problem.
What?
No, we are not done with this problem. They want you to calculate the C value. They want you to actually find the C value. So we need to go back and figure out what C value is in the interval from 0 to 5 that actually made this function equal 11. How are we going to figure that out? Without a graphing calculator, how are you going to figure it out? Set the function equal to 11. So, let's do that. If we set this function equal to 11, we get x squared plus x minus 1 equals 11. I need to know what x value made this function equal 11. How do we solve this? Subtract 11. We get x squared plus x. If I subtract 11, I get minus 12 equals 0. What two numbers multiply to a negative 12 that add to 1? 4 and 3. X plus 4 and x minus 3. So if I solve that, I get x equals negative 4 and x equals positive 3. Which one of those is in the interval that I'm looking at? Yeah, positive 3 is the C value in that interval that makes this equation true. So put a box around positive 3.
That's our C value?
That's your C value. So if you plug 3 into the function, it will make that function equal 11. Whew!
Wait, but we're not